Welcome back.
Hello.
Hello. So I wanted to give some particular examples of theories of upper ontology, and we can talk about how they've affected the development of computational representation. So ontology and most of Western civilization all descends from Aristotle. I've given you some Aristotle to read. I hope some of you have had a chance to have a look at it. Computer scientists aren't used to reading anything older than last year's NIPS conference proceedings. So reading something this old may be surprising or difficult for some of you. It's like that for everyone who tries to read texts that are this old, and it's part of the experience. You get to feel contact with the very beginning of Western society and try and figure out what it means. Many of the words have changed their meanings over time, and different translations will have a biased opinion about what the words are actually supposed to mean. So let me just try and explain how old this actually is, right? This is the history of the world for computer scientists. It's all the bits that actually matter. And you will find that Aristotle exists right at the beginning of kind of real verifiable history and civilization. There's stuff that comes from before Aristotle's time. There were cities developing around minus 4,000 years. But in texts from these kinds of times, you're never quite sure what is a myth and what is real and what is fiction, and everyone is talking about gods and spirits and heroes who live to be 1,000 years old and so on. When you get to about 1,200, there was what is called the Bronze Age collapse took place. Some kind of catastrophic event occurred, and civilization as known until then largely fell apart and was reconstructed. And so you find there are a lot of stories from around this time that exist right on the brink of history and myth. You will find there's the story of Moses crossing the Red Sea, which has some relationship to the archaeological record of the Hyksos people moving from Egypt to Israel at around this time. You'll find the story of Troy, which has some relationship to actual archaeological ruins of Troy. And you find the very earliest Vedic texts, the Rig Vedas, from this point. So from this time on, we're pretty sure about who lived when and who wrote what. You'll find that the oldest fragments of the Tanakh, the Old Testament in Christianity, show up around 800. You find, I think, almost overlapping with one another. Socrates, Pythagoras, Confucius, and Buddha all showed up around this time. And these are all people we're pretty certain were real people, and we have historical records of things they did, but with some confusion about exactly which of those are real and which were written much later by other people. When you get to Aristotle, we are very definitely sure who Aristotle was and where he worked. We've dug up his school. He created the Lyceum, which was one of the first university-like institutions. And we have the actual text as written by Aristotle, and that text has been passed down pretty much all through Western civilization until a few years ago, possibly. Not much happened in philosophy for a long time. There was 1,000 years when people just read Aristotle and passed it on from one generation to another. So this is before the Tanakh was finished. It's before the Antikythera mechanism, before Muhammad, before the printing press, and then modernity. All the the logical developments we've been studying. So Aristotle is very, very old, and when you encounter this text, you have to put it into that context and understand it was the first time that anyone had tried to think about these ideas and to put them into words. So most of Aristotle's writing has been lost. What we have left is mostly bits of what are thought to be lecture notes. Nobody knows what order they're supposed to be put in, really. There are many scholars who have argued and come up with a consensus about how they should be presented, at least for modern readers. And this work called The Categories is traditionally placed and read first, because it deals with ontology, and ontology is the basic knowledge you need to be able to talk about anything else. So, if Aristotle is the foundation of Western civilization, this is the foundation of Aristotle. So this is the almost the definitive starting point for Western civilization you have in your hands when you read this document. It's all written in Greek. We read it in English translations, and those translators are all biased. They all have their own opinions about what it was that Aristotle actually meant. Both the Greek words and the English words have drifted over time, and so nobody really agrees what it means anymore. You are not expected to read this and understand what Aristotle actually meant, because probably nobody does anymore. But rather, it is a text which generations of people, and especially designers of programming languages and databases and so forth, and AI systems, they have all turned to this text as a source of inspiration. It is a place where you can go to get ideas about ontology. And probably your reading of it will not match anyone else's reading. You will have your own ideas that are suggested to you by this text. And maybe those ideas will help you make the next great programming language or AI system. Just don't expect to agree with anybody else. If you want a mainstream reading of it, I've given you a link down here. I'm going to tell you about my reading of it. That will be different from your reading and anybody else's. So the categories is the source of these most basic concepts. Aristotle divides entities into simples and complexes, and simples gives you substances and predicates. A predicate is something that you can say about a substance or substances. Substance, you can't actually say much about them. Substances exist, they are entities, they have unique identities. So this substance is different from that substance. Usually they persist over time, but they can change over time. They can change their properties over time. But that's all you can say about substance, because anything you say about a particular substance is a predicate. It's not part of the substance itself. So predicates are easier to understand. Predicates split into what we call today properties and relations. And a property is a predicate that is in a substance. So the color or the age or the charge or the quantum spin of a substance, there's a sense that it belongs inside the substance as an inherent part of what that substance is. Whereas a relation is something that you say of a substance but isn't in the substance. So for example, the owner of this car, or the cash value of this car, that's a predicate about the car, but it's not inside the car. That's a very complicated function of how human beings relate to the car and to one another, and how much cash value they associate with it. The location of the car, you can take the same car and move it around, but in a sense it is still the same car, even though this predicate has changed about its location. And yeah, relations like brotherhood we've talked about, where you are inherently talking about several substances at the same time. And then complex entities are things like this. John's brother runs to the shop. There's a whole load of substances and properties that have been put together using grammar to make something. more complex. So the first confusing thing about the categories is it tries to give two different descriptions of ontology that are quite possibly from entirely different pieces of text that somebody ran together at any time in the 1,000 years after he wrote them. And these are called the fourfold division and tenfold division. So the fourfold one is the simpler of the two, and I would read it as this 2x2 matrix, like a good MBA student. Everything's a 2x2 matrix on an MBA course. So the fourfold division divides entities into things that are said of versus not said of, and things that are present in and not present in. Okay, so the easiest one to understand is a property. A property is something that is said of something else, and it is also present in that thing. You know, the redness of the apple is, in a sense, in the apple. Whereas a relation is something that is said of but is not present in. Things that cannot be said are unsurprisingly harder to understand because you can't say them. Can something exist that you can't speak of or describe? And as computer scientists, I think the way to understand this is to think about C++ and memory and representation. Okay, when you represent a world in a language like C++, let's say you're building the game. Okay, there are certain things that are in the world, and when you say things, you're talking about the world that is being represented. So the position of my spaceship is something I can say. You know, the spaceship, the name of the spaceship is something I can say. But there are other entities regarding that spaceship which cannot be spoken about inside the game. So, for example, the location in memory at which that spaceship is stored. You know, that's something, as a programmer, you can see it. You can get a pointer and see its address, but that address does not show up inside the game. It's not a property of the world that we're representing. And similarly for properties, that spaceship contains a bunch of variables that are instantiated, and you know, the energy level of this spaceship could be different from the energy of that spaceship because they're stored at two different memory locations. So these are things that are outside the world that we can actually speak of. But they're important when you try to define equality, and any programming language designer has to deal with this. What does it mean for two objects to be equal is a very difficult question in ontology. You know, naively, you may think that A equals B if any property of A is also said of B. Okay? So roughly this means, you know, my car is red. Matthew?
Sorry, before we go on to equality, I still don't quite understand the separation between your substance ID and your property ID analogy.
So the substance, okay, imagine I've got two substances. Actually, this is inherently tied up with equality, so I'll talk about them both at once, right, to answer your question. Suppose I have two substances, right? And yeah, we can give them names, but remember that the name of a substance is a property. So that's different from the identity of a substance. You know, the identity of a substance is, in this case, where we're instantiating it in the computer's memory. So suppose I have these two substances, right? I'm going to make new Space Invader, and then I'm going to make another new Space Invader. Okay, and I'm going to set all the properties of the first Space Invader to a set of values. You know, energy equals 3, position equals 4. And then I'm going to set all the properties of the second Space Invader to the same values. Okay, so I've now got two Space Invaders in my memory, and they all have exactly the same properties. And the question is, are they equal? Are they the same Space Invader? or if you think that question has no meaning, a better question is, should they be equal? You're the compiler writer. Are you going to define them as being equal or not? They're sat at two different memory locations, but their properties are all exactly the same.
I would have thought of that as like a difference in data formatting rather than ontological difference. But well, I guess we aren't comparing their. Yeah, I guess it depends on like at what level you want to compare it, which is what you're saying at the bottom here. Like, because realistically, within the system, we don't really care about, say, if they got two different memory addresses. Like you say, that's not actually part of what we're looking from inside the system. It's part of the ontology, but it's not part of our system.
Yeah, we're trying to build a world here, and within the world, they have the same properties.
Yeah. So yeah. So on some sense, it makes sense to say they're equal, but obviously because they're different, they're not the same.
So yeah, if you compare their pages, they'll be different, but if you compare their properties, they're the same. Yeah. So within the world, they seem to be the same Space Invader, but outside the system, they look like different Space Invaders. So you can also split this up, or do you only care about properties, or do you care about things that are said of? So if there are two Space Invaders and they have all the same properties, but one of them belongs to Fred and the other one belongs to John, can you still say they're equal? Yeah, they're sat there, they're in the same position, they have the same mass, they have the same color, but one of them is John's and one of them is Fred's. You've got different relations applying to them now. And again, you can argue this either way, and as a language designer, you're going to have to choose. And this is a big thing about relations, right? If you've decided to represent relations in a way that isn't inside the objects, you may end up with a different choice here than if the relations are inside the objects. How can you test two things for equality if their equality depends on something that is in some other place that you might not even know if it exists or not? Someone's gone and instantiated an ownership relation with Fred in some other part of memory, and it's got a pointer to your object and to Fred, and no one ever told you that had been done. So is the thing still equal or is it not?
It's like if because we did the computable numbers the other lesson, it's like maybe even asking the difference between is it equal if the algorithms are equivalent, or is it equal if it has the same number and if it halts, kind of difference.
So the difference between a sense and a reference, yeah? Are we talking about the actual thing being referred to, or are we talking about the description of it, of how to get there? Yeah, good. So you can then start to ask questions like this: can a predicate exist without a host substance? This is a big Aristotle contribution. Is there this thing called red? My car has redness as a property, right? But what is this redness? Does red exist independently of my car? And are we going to be allowed to talk about red by itself unless someone has a car that is red? So can we do logic about red? You might have a rule that says if you take a color and make it darker, you get a new color. Or you might have a rule that says red and yellow makes orange. What exactly is going on there? Because you have this thing which was supposed to be a property called red, and it now seems to be behaving like a substance. It's something that can have its own properties. You can say, is red bright? And now bright seems to be a property of another property. Or you can turn it into a noun in English. You can take capital letter red and talk about redness as a substance or a noun. And if you want to build an AI system, it's going to have to deal with things like this. Someone can come in and type in this question: is red red? Where red is this abstract substance, apparently, and this red is a property of that substance. So how are you going to represent this? How are you going to represent this abstract red entity whilst also having instantiated lowercase red properties? And this leads to the possibly the only ontology joke. I was going to say the most famous ontology joke, which is what's red and invisible. I'm going to let you think about that. What's red and invisible? Okay, so that's the fourfold division. Okay, so yeah, this distinction in particular is argued about, very hard for anyone to understand or interpret. To my reading, the substance ID seems like instantiating an object somewhere in memory. It's the address of where that object is, and the property ID is the address of one of the members of that object. Substances can change their properties. The Catholics have the greatest philosophical hack of all time when it was discovered that the bread and the wine they drink, which turns into the flesh and blood of Christ. Somebody measured it and discovered that it hadn't actually changed any of its properties when it had been ingested by a human being, which created a huge theological dilemma because it's the basis of a large part of Catholicism. And so the greatest philosophical hack of all time was that it was decided that the substance changes, but the properties remain the same. So the substance ID changes. Okay, when you eat the bread, it becomes a different substance. It ceases to be the bread and it becomes the body of Christ. But all the properties of that piece of body of Christ inherit their values from the properties of the bread. So if you weigh it or check its color, or burn it and see how many calories come off, all the properties are the same, but the substance ID has changed.
So in other words, Jesus is now more bread than human.
The thing that you put in your mouth has become part of Jesus. So there's more Jesus than there was earlier, and there's less bread. But it just has the same properties that it had before.
Well, it's not like there's more Jesus. It is Jesus. It also just happens that it's Jesus with all the properties of bread and wine.
He's probably
That's
got
actually really interesting. I'm thinking of that from like a language perspective, like a programming perspective, and like how you'd actually map that out in data.
This stuff actually matters, right? When you design a language and you're testing whether things are equal, you actually have to implement this, and you've got to make a decision about what these things are going to be. Okay,
it's like
so that's
having like a semantic type, which has which mirrors all of the properties of any other type, like a monad. It's like a monad. It's like a burrito. It's actually exactly like a monad. That's terrifying.
Right, look, let's go on to the tenfold division. Okay, so no one can agree on whether the tenfold division competes with the fourfold division or whether they're compatible with each other, and it's some kind of zooming in of the fourfold one. But in the tenfold one, you get a division of entities into 10. So here you've got substance again. So this is a list of the basic categories which exist. That's why it's called the categories, the 10 categories of existence. You have substance, you have quantity, quality, you have relations, you have space in itself, the existence of space, you have the existence of time, you have the existence of being at a location, which is kind of another form of property. You can see properties here are sort of divided into quantities and qualities and all this stuff. These are other things that you can say about a substance. You have the property of being at a location. There's the property of having. You say John has a ball, and this havingness is something you can say about John. There is action, as in the creation, initiation of actions by a sentient being, and there is what is called passion, or being acted upon. So the word passion comes from passive or passivity. If you're acting, you're the one who's doing the verb. If you're being acted on, you're the object of the verb. Your emotions are called passions because the Greeks thought it was the gods or someone putting those emotions into your head. You're being acted on by something outside when you get emotional, rather than you making the decision to be like that. So this list gets argued about a lot. Why should there be 10? Why did God make 10 categories rather than 12 or 9? And there are all kinds of things that seem to be missing. Why have we got being at a location but we haven't got being at a time? What about being a member of a class? Or does that come under one of these other things, quantity or quality? If so, why? Or is it a relation between the object and the class? So if you read through this, you will argue with it, and it's really that process of arguing that is the useful part, rather than agreeing with what Aristotle may or may not have meant by any of it. But it will help you to think about ontology and to come up with your own ideas for ontology. So in particular, Aristotle has a weird lack of the notion of class in his ontology. For Aristotle, class membership is really just another predicate. In his other writings about biology, Aristotle talks a lot about genus and species, right? So you are a member of the species Homo sapiens, and Homo sapiens is a member of the genus Homo, which also includes monkeys and apes and stuff. Roughly species means class, and genus means superclass. And a synonym for Aristotle is two species of the same genus. You can take out a man and replace it with a monkey, and they are synonymous. So the meaning of synonym has changed over time. Right? Nowadays, it normally means two words for exactly the same thing, but in Aristotle, it means two subclasses of the same class. But look, he handles this class membership as a form of predicate, and this has come straight into systems like Prolog. When you say X is red, you can apply it as a predicate. You say red of X. But you could equally have written it like this. You could have had a relation called color, and you say X is related to this non-physical other entity called red with a capital R. And this is a different ontology for expressing the redness of X. But this is where you get confused as an object-oriented programmer, right? You could say that class X is extending the class of red things, right? You can say this object is a red thing. It is a member of the class of red things. You might even say it is of type red things in some cases. These are all different ways of trying to express the same idea. So for Aristotle, being a red thing is definitely a predicate. It's something that you say about X, rather than X being a member of something. And this may make you question some of your object-oriented practices. You will often have class animal and class cat extends class animal, but then class cat has a property called color, and the color might be red. But for Aristotle, there's no difference between being an animal and being red. You're in the class of animals and you're in the class of red things. And equivalently, one of your properties is having animalness, and another property is having redness. And from this perspective, it seems like a very weird thing to do, to pick just one of your many properties, such as animalness, and make this big deal about it in your programming language, that your class cat is going to extend from animal and only animal, and all its other properties, like its color, are going to exist as internal properties rather than class membership. So you then get into trouble when you try and make X the member of class animal and also class red things. And in C++, this becomes multiple inheritance with all the fun and games that ensues. So Aristotle disagreed with his teacher Plato. This is Aristotle. This is Plato. Plato is fairly historically real as well. Socrates, or Plato wrote about Socrates, but we don't have writing from Socrates. So this is a famous picture illustrating their disagreement, and you can see Plato is pointing up at the sky and Aristotle is pointing down at the ground, because Plato believes in this other world of forms, of abstract entities, which are non-physical, so they're not actually above him in the sky, but it's a metaphor. Whereas Aristotle doesn't. Aristotle only believes in stuff that is here in the world. So he's pointing down at the ground and looking at nature, bottom up. This is the original top-down and bottom-up thinking. So Plato's thinking is more like what you get in an object-oriented language, where you have this thing called a form. The form of animals is the abstract structure of all animals, or the form of red things is the abstract structure of all red things. And any particular object is going to be an instance of a form, or what we now call a class. So Aristotle disagreed with this because he said, where are the forms? Where is this abstract animal of which you speak? You can't point to it like I'm pointing to this cat on the ground. They don't exist in time and space. Easier in computer science. We're quite happy that there can be a class animal sitting at a location in memory, and that has all the information about the class. And it's not inside the simulated world. There's something that does exist, but not within the world. It exists outside the system. So these forms have a similar status to the substance ID and the property ID. They're not something that can be talked about inside the world that they're in. So that's a short view of Aristotle and Plato. Let's look at another proposed ontology from more recently, and this is the one that really shows up in a lot of databases and in Prolog in particular. This is from Russell and Wittgenstein, early 20th century, and this is called the logical atomist view of the world. So for logical atomists, we have a different ontology. We say the world is made of facts, not of things. And we also have a logical picture of the facts called a thought, and this is the noumenal world and the phenomenal world. And we're claiming here that they have the same structure, and therefore you can use one to represent the other. But in these facts, you get a very simple ontology, and you basically just have substances and relations, and that's it. So, as with Aristotle, you can't say, by definition, you can't say anything about a substance, because that would be a predicate or a relation in this case. But outside the system, you can say there are things that have unique identities. You can informally give them names like substance 1 and substance 2. But then anything else you're going to say becomes a relation. So in this case, properties are just relations taking one variable. So if you write man of substance 1, you're endowing this substance, which you've nicknamed number 1, you're endowing it with this relation of being a man, or of manhood, which for Aristotle would have been a property, but here it's a relation of a single variable. There's no concept here of whether the relation is in the substance or not. Okay, that's a purely Aristotelian thing. So, saying that object 1 is a man is no different from saying, object 1 is public property, right? That's making a claim about the ownership of object 1. They're both single place predicates. But for Aristotle, the manhood of substance one would be inside the substance, and the ownership of it would be outside. For logical atomists, there's no difference because they're just relations. And you can also represent arbitrary relations like brotherhood and functions. A function is just a map from a bunch of stuff to another stuff. So everything then becomes a relation. So you can say substance one is a man, substance one is red. You can say substance one and two are brothers. You could, if you believe you've got some concept of number already set up, you can say the age, give numerical values. You could make claims about location in this way. Here's an is-at relation. Here's a particular location. And you can make class membership relations. You can say substance one is a man. And all these things have the same status. And yeah, this is what you find in SQL, and it's what you find in Prolog that have evolved directly out of logical atomism. In Prolog, the substances are called atoms for this reason. It's a direct inheritance. So people will then argue about how to set up numbers and functions and locations and times and so on. If you like this view of the world, Wittgenstein's Tractatus is the famous Lehard presentation of it. The best way to read the Tractatus is online because it is written as a series of drop-down menus, effectively. Ideally, you'd open it up in Vim and put it into folding mode because it's all written as bullet points and sub-bullet points. So there's a web page here. There are, I think, 7 basic propositions, and they each open up with sub-propositions and sub-sub-propositions. But it's roughly describing the design of Prolog, or first-order logic. If you don't like Wittgenstein's presentation, then Russell's presentation is this one. This is Russell on logical atomism. Less well known than Wittgenstein, but much easier to read because it's actually in English rather than in logical bullet points. Gives you an easier view. But you can trace here the development of what are called relational systems. The relational databases are so called because everything's a relation, except for the atomic substances. If you like human languages and logic, then take a look at Lojban. This is a constructed language, somewhat like Esperanto, which is specifically based on this logical atomist philosophy. And again, you will find there are substances which have names, like John, and in Lojban they're called communes. And then you have these n-place relations, or gizmu, which are roughly verbs and properties joined together. So giving is a verb, and it's a function of several arguments. Giving involves the person doing the giving, the person it's being given to. It involves the thing that is being given, the object, and it might have some optional arguments like a location and a time where the giving is being done, or sometimes the instrument by which the giving is being done. John gives the toy head using the robot arm in the study at midnight. And so verbs and other relations like properties are explicitly defined formally as functions taking these inputs. So the result of this is that, unlike Esperanto, Lojban has a fully formal definition, and that means you can very easily process it computationally. So it's really been designed as an intermediate language, somewhere between a human language and a computational language. So it shows up in applications in NLP and AI and ontology, where you want to almost be able to speak to the computer. You can say things like this, right? Me prichu lo dansi bilo mapku. I am the right of someone who wears a hat. But you can put that into your Lojban compiler, and it will definitely compile like a computer language, because everything has a perfectly formal definition. It's also less European biased than Esperanto. Esperanto is taking its vocabulary from Latin and European languages, whereas large band vocabulary is statistically sampled from all the languages in the world to have a completely unbiased collection of morphemes, the basic sounds for person and hat and so on. So in philosophy, no one is a logical atomist anymore. They've gone back to a more Aristotelian view of the world, but in AI, we're still stuck with it, which maybe gives some indication of what has gone wrong with AI and what we should do to get it back. There are well-known problems with logical atomism, and they're still there in Prolog and SQL. So for the philosophers, the big one has been, why should the world have the same structure as thought? Why should the actual noumenal world be made out of first-order logic in the same way as human perception? There's no obvious reason why those things should really exist in the same way. We don't really care about that because we only like the phenomenal world. More troubling for us are issues like this. Okay, logical atomism assumes that any fact can either be the case or not be the case, and everything else remains the same. The facts are all independent of each other, and they have to be in order to exist as fundamental entities. But what about facts like this, right? The color at location 356 is red, and the color at location 356 is green. You can't have both of these facts. They don't explicitly contradict one another. This thing, when you're not directly saying X and not X, but you're giving two facts which just can't both be true at the same time, and one of them has to go. Or John can't be king at the same time that James is king, because there can only be one king. Most concepts are impossible to define. Okay, so Wittgenstein later fell out with all this, and he argued against his own former philosophy, mostly by going on and on and on about what is a game. You might think you have a definition of what is a game. It's an activity for two players with a scoring system, and someone wins and someone loses. Does it have to be zero sum? Can it be cooperative? In game theory, there are cooperative games. Does it have to have two players? Is rock climbing a game because you do it by yourself? Is war a game? War is a game with serious consequences. Does a game have to be something that is only done for fun? And you can go on and on and on. And any definition you try and propose for what is a game, you can come up with a counter example of something that doesn't fit it anymore. So it seems these concepts are very hard to pin down in the first place. There are objects that are very hard to separate. What is a pile? One pile of sand. What happens if you take a grain of sand out of the pile and put it somewhere else? Is the pile still the same pile or a different pile? These things are fluid, and it's not a rigorous definition of what is one pile. And then our friend Hofstadter has most recently argued against the whole thing with this idea of fluid concepts. This is a wonderful book full of his natural research. Gödel Bach is a popular science book. These are real research papers. And fluid concepts is all about how humans perceive the same pieces of the world in different ways for different purposes. So, for example, this is called a Necker cube. And you can perceive it in two different ways, right? This corner may be at the top and closest to you. That's how you normally perceive the thing. It's popping out at you. But you might also perceive this corner as being at the front. Okay, this is at the bottom left and it's at the front. So the front face of the whole thing is here. And the rest of the cube is going backwards, like that. And what you have here is the same underlying state of the world, but you're perceiving it in two entirely different ways. You can do it in music as well. You can interpret this rhythm either as a military snare drum marching pattern going da 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 da, or alternatively as a drum and bass pattern going dum ch dum ch. They're exactly the same rhythm, but if you chunk it in these different ways, you'll hear the two different sounds. So somehow two different objects come into being out of the same underlying physical law. And if you talk to chess players, for example, they'll perceive the state of a chessboard in a very specific way. They'll cluster pieces into objects. This is a defensive structure. This is a known thing about putting your queen in between two castles, whatever. Different players will chunk the board up differently, and they'll see it in different ways. And a big skill in chess is learning to see the board as your opponent sees it. It's this idea of, like we said before, modeling someone else's phenomenal world. And your opponent might be less good than you. They might decide to chunk these pieces together as a thing, and you wouldn't normally do that. But if your opponent is going to do that, then you have to at least model their model of what is going on. So these are all different ways to break down logical atomism. This claim that the world is made out of facts seems to fall apart when you look at how humans actually construct these facts and how fluidly those facts can change in response to the same underlying piece of reality. So Hofstad is one of the few people who's taken this seriously and actually tried to build AI models of fluid concepts. And he started doing that at a time when everyone else was using Prolog and logical atomism. And we're seeing all the same problems now show up in data science, which is ultimately based on SQL and relational databases, which view the world in a fixed, non-fluid form. So yeah, this also shows up in the object relational impedance mismatch, right? You have the object-oriented or Aristotelian view of the world, everything object with properties, maybe apart from relations which are messy. And you have this problem in object-oriented programming that the languages don't usually distinguish between objects in the world that you are representing and objects that are purely computational data structures, things like the substance ID that only exist outside of the simulated world. You have these problems with equality sitting there too as a result. The other side is you can go for this philosophically more recent atomist view of the world. This is what you find in SQL and Prolog, where everything is a relation. And in particular, this makes it very easy to create new relations at runtime on the fly. If you've done SQL, you can select different groupings of properties and put them together into new relations. You can say select age, number of legs, and height from all the cats, and you now have this data frame containing a brand new relation, maybe a four-way relation between the three things you asked for and the identities of the underlying substances. And this leads to a huge mess when you try and interface object-oriented languages with SQL, because you'll give queries like that, and what comes back is this horrible thing called a data frame, which is a computational object representing a matrix full of data. And that isn't what your world is supposed to be. Your world is supposed to be full of tables and chairs of cats, and the object you've got is a data frame representing a matrix full of data. And it's the wrong level of abstraction to be working at. You'd like to be able to hit on the database and say, give me the actual cats in the world, but you can't because the databases are constructing these new relations on the fly, which you don't have a class definition for. So this is a very well-known ontological problem, and people spend a lot of time coming up with fixes and hacks in code bases. So I used to get paid quite nicely, actually, to do this every day. They'd written the database in SQL, they wanted a visual basic object-oriented front end to it, and the SQL doesn't fit in the Visual Basic, so you need to write all these helper functions to convert relational stuff into objects, which is kind of tedious, but nicely paid, and is basically endless work until we solve the underlying ontological issue of how to merge Aristotle's ontology with Wittgenstein's. That's not going to happen anytime soon. Should we have another cup of tea?
Sounds good.
It's time, 10 minutes. See you then.
Yep, see you in 10 minutes.